Hello there. Today I want to talk to you about how to use large language models for your business. Are you going to use prompt engineering or fine tuning or RAG or a combination of all these? Let's get started. Putting LLMs in production and using them to solve your business problems is pretty challenging. There is no one-stop shop and this field is evolving very fast. So let's take an example. Let's say an international law firm which operates in many countries, multiple jurisdictions, wants to use LLMs to craft case documents or analyze cases, compare cases. Using a foundation model will not do it. It won't cut it because even though foundational models understand language, have knowledge of the world, have reasoning capability, they lack legal domain knowledge, right? So you have to train the foundation model on your domain knowledge. All right, let's move forward. Okay, so to extend model knowledge and use it for business, here is a high level framework. I'll talk at a high level on the 3 tracks and then we'll do a deep dive into each one of them. The first track is using the model as is. Here the model is not modified. You use a technique called prompt engineering where you are essentially creating a prompt, you're crafting a prompt with examples, giving guardrails in a manner to instruct the model to execute your requirement. Okay, so the benefit of this is you can do fast experimentation, it is low tech, you can fail fast, and the model is not modified. All right, so this is track 1. Now within track 1, if this doesn't work, there is a technique called RAG, Retrieval-Augmented Generation. Again, the model is not modified, and essentially what you're doing is you are, in addition to the prompt, you are supplying it content or context. So you combine the prompt and the context, and this context or this content is retrieved from your external systems. So I'll talk more about it, but using vector databases, you can supply the relevant context, add it to the prompt, and give it to the LLM to execute upon it. Now, this is more costly because you have hardware and software stacks to maintain. You have to maintain, update, create a vector database. You need programs to extract your PDFs and your text files, convert them into vector format, store it there, and then retrieve it. So I'll talk more about it, but at a high level, this is track 1. The benefit of this is you don't modify the model, so you can do model switching, or you can use different models for different use cases, right? So this is track 1. Let's see what track 2 is. Okay, track 2 is fine tuning. All right, so here the model is modified and I'm going to talk about techniques, but essentially what you're doing is you are taking a base model, you are training it using fine tuning techniques on your own data, and then you're going to use it. This is much higher cost, it takes more time to do, it is complex, and you have to train the model, you have to deploy it, you have to monitor it, so it's pretty expensive. Okay, but for complex use cases, or maybe if you're creating an AI product, or you're a large business in healthcare or law, maybe this is the way you go. Okay, so that's track number 2. And then the track number 3 is where you create your own custom model. Okay, this is basically build your own. It's very, very high complexity, very, very high cost, and only very, very big companies can do this. I'm not gonna talk about track 3. I'm just gonna talk about track 1 and track 2 and do a deep dive on those. So let's move forward. Okay, so let's talk about prompt engineering. Prompt engineering is the process of designing your prompt so that the AI model can understand it and it can act upon it to provide you the desired results. A prompt basically consists of clear requirements, instructions, guardrails, along with the data and examples so that your model can act upon it and provide you with the desired output. There are different types of prompts. A zero-shot prompt is where you just provide your request or command using natural language and the model understands and executes it on your behalf. The use cases are language translation or sentiment analysis. A one-shot prompt is where you give one example of the output, of the desired output format or structure you want, along with the prompt, and that way the AI model knows how to, provide you with the correct output. Few shot prompt is where you provide a few examples along with the task request, guardrails, instructions. This is more complex, and I'm gonna show you an example so that the AI model can act upon it, can reason through the prompt, has data to look, examples to look at, and it can execute and give you the right desired output. Chain of thought is where you instruct the model to work on a problem and think through it step by step. I'll show you an example of this one as well. Okay, so let's walk through an example. This is a few shot prompt used in customer automation chatbot. My objective is for the model to analyze a customer inquiry and return to me which category it falls in. That is, what is the intent of the customer inquiry. So here I'm giving it a style and a tone. I'm instructing the model to analyze the customer inquiry and return the intent in one of these predefined categories. I'm also giving it guardrails not to provide any long notes or explanations. Then a few examples, and then I ask it the question for the below customer inquiry, what is the service category? So the question coming from a customer is, my wallet got stolen. It was in my bag at a conference. It had my credit card. What should I do? And I'm just gonna change it and execute it. And hey, I got back lost card. So that is the intent of this customer inquiry. So this is an example where in your application stack, you're gonna make an API call to the AI model, provided this prompt in this manner, and you can get the intent of customer inquiry. It's a typical use case for customer service automation apps. Let's talk about chain of thought prompting. So here is a simple example, and I want the model to walk through it step by step. So you can read through it, and the model comes back, it walks through it and gives me the right answer. So this is an example of chain of thought prompt. Okay, so let's talk about RAG, Retrieval-Augmented Generation. In simple words, RAG is a technique where you are adding relevant content to your prompt and sending it to the large language model. Okay, so this is a pattern which you're going to use for more complex use cases where you have a large corpus of domain knowledge, business knowledge residing externally in structured and unstructured data over here, and you want to create an application which works on this, like a Q&A application, or you want your large language model to do reasoning over this, to do semantic search on this. Okay, so this is RAG in simple words. Now if you go back over here, so we are over here. So in this use case, the model is still not changed. We are using the model as is, but the complexity has gone up because you have to set up this pipeline. So let's take a deep dive and understand what this entails. All right, so a typical RAG application architecture looks like this. uh, you would actually need to first ingest all your corporate documents, structured, unstructured data into a vector database, because the language of large language models is embeddings. Okay, so the first step is setting up a ingestion process in your company. This would involve quite some lot of amount of work. So that's why the complexity is pretty high. The prerequisite is convert all your documents, structured, unstructured, multi-format, into embeddings and put them in a vector database. Once that's done, your application, you can, when a user puts in the prompt, you would need to convert that prompt to an embedding, search against the vector database to retrieve relevant content, and then add that content to the prompt and send it to the large language model. So I won't go too much into detail, but I suggest you watch my video on RAG. It is very detailed and it also has a demo. All right. But as you can see, the key thing I want you to take away is this is pretty complex, right? Even though we are not changing the model, involves setting up hardware and software stacks, and it takes quite some amount of work. So as I said over here, we are going up in complexity, we are going up in cost, but the accuracy is also going up. Prompt engineering is limited, whereas RAG, now you have the opportunity to do Gen AI over your custom documents, business knowledge. So hope you get the point. All right, so let's talk about fine tuning, which is on track 2, and here the model is modified. So fine tuning is a technique where you are gonna train the foundation model on your own business data, on your own business knowledge. Now, let's take an example. Why would you need to do that? So let's say Boeing as a company, right? Boeing wants to create an AI assistant which helps new employees train on aeronautical engineering. Okay. Now, the foundation models out there, they have knowledge about the world. They understand language. They understand the semantics of language. They have reasoning power, but they have no knowledge about aeronautical engineering, which focuses on designing, developing, producing aircrafts. All right. Now, to use this model for a AI assistant, you have to train it. Right? So that process is called fine tuning, where you take your domain specific data and fine tune it so that the resulting model becomes a custom model. Now it has knowledge about your business domain, okay? And you can create AI assistants and you can use it in your workflow. So if you look over here, however, fine-tuning has challenges, okay? Because these large language models are so big, adjusting the weights and changing the model is very compute extensive. It is very expensive and it's out of the reach of many companies. It takes a lot of time, expertise, and it's very time consuming. So to address these challenges, techniques have evolved, and we're going to talk about 2 of them over here. This technique is called parameter efficient fine tuning, where only a limited number of the model's parameters are modified, and the bulk of the foundation model's parameters remain unchanged. So let's take a deep dive. Okay. So low rank adaptation is a type of efficient fine tuning technique where the model's parameters are frozen and new parameters are added which are trained. Okay, so let me show you by example, and I suggest you look at my video on YouTube where I explain this in detail along with a demo. But what I did is I took an open source gamma model. it has around 2.5 billion parameters. You can see it over here. And now I fine-tuned it. Okay. So it says over here the trainable parameters are to around 2.5 billion, and I using code I basically started to fine tune it, and using LoRa technique, as you see over here, it says that the non-trainable parameters are now 2.5 billion. So we are freezing the model's parameters, we are freezing them, and then we are inserting a limited small number of low rank parameters, and we train the model on top of that. So this is much more efficient. Even though the model is changing, it is a much more efficient technique. So that's that. And then the other technique is quantized low rank adaptation. So this takes low rank adaptation further by reducing the size of the weights. Usually the model weights are stored in float 32. Now using this technique, they are shrunk down, and so this decreases the size of the overall model. So that's that, and if you want details, you can look at my video and you can Google on the internet, but high level conceptually you understand now. And coming back over here, this track we saw the models weights do get modified in fine-tuning, and you usually in companies, when you start your AI journey, you're gonna start over here. All right, and most of your use cases can be covered using prompt engineering and RAG techniques. You don't need to go over here, but for big companies and complex use cases, you might go over here. So you start your journey over here, and then you do RAG, you do prompt engineering, you do both, and then you get comfortable, and then you go over here for the more complex use cases. And for bigger companies and maybe product based companies, or very very big companies, then maybe you create your own brand new custom models. So I hope you got the overall picture of how to unlock the potential of LLMs for your business and the various techniques available. Thank you.